Numbers are everywhere. They are an integral part of our daily lives, and we encounter them in various forms and situations. We use them to count, measure, and label things. From the moment we wake up and check the time, to when we go shopping and look at prices, numbers guide us. As we delve deeper into the world of mathematics, we discover new and interesting types of numbers that help us understand the world better. One such fascinating type is the rational number. These numbers are not just abstract concepts, they have practical applications in our everyday lives. So, what exactly is a rational number? How do we identify and use them? Simply put, a rational number is any number that can be written in the form of p over q, where p and q are integers, and q is not zero. This means that rational numbers can be expressed as fractions. This means we can express a rational number as a fraction, where both the numerator, or top number, and the denominator, or bottom number, are whole numbers, and the denominator is not zero. This simple definition opens up a world of possibilities. Understanding rational numbers is important because they pop up everywhere in mathematics and in real life. They are the building blocks for many mathematical concepts. From dividing a pizza amongst friends, where each slice represents a fraction of the whole, to calculating discounts at a store, where percentages are essentially fractions of 100, rational numbers are our everyday companions. They help us make sense of the world and solve practical problems. Mastering rational numbers opens the door to understanding more complex mathematical concepts and builds a strong foundation for your future math journey. With a solid grasp of rational numbers, you are well on your way to becoming proficient in mathematics. We can visually represent numbers using a number line. This is a fundamental concept in mathematics that helps us understand the position and value of numbers in a clear and straightforward way. A number line is like a ruler that extends infinitely in both directions. It allows us to see the relationship between numbers, whether they are large or small, positive or negative. The middle point of the number line is usually 0. This central point acts as a reference from which we measure all other numbers. Numbers to the right of 0 are positive, and numbers to the left of 0 are negative. This helps us easily distinguish between values that are greater than 0 and those that are less. But how do we represent rational numbers, which are fractions, on a number line? This might seem tricky at first, but it's actually quite manageable with a bit of practice. It's simpler than you might think. Once you understand the basic principle, you'll find it easy to place fractions accurately on the number line. Imagine dividing the space between each whole number on the number line into equal parts. This division helps us pinpoint the exact location of fractions. The number of parts depends on the denominator of the fraction. The denominator tells us into how many equal parts the space between whole numbers should be divided. For example, to represent 1/2, we divide the space between 0 and 1 into 2 equal parts and mark the point that represents 1/2. This method can be applied to any fraction, making the number line a versatile tool for understanding all types of numbers. We've already learned that rational numbers can be written as fractions. But are all fractions rational numbers? The answer is yes. Since fractions are represented in the form of p over q, where p and q are integers and q is not 0, they fit perfectly into the definition of a rational number. Let's look at some examples. The fraction 3/4 represents the rational number 3/4. Similarly, the fraction -5/7 represents the rational number -5/7. Remember, even fractions that can be simplified, like 4/6, which simplifies to 2/3, are still rational numbers. Just like whole numbers, rational numbers can be positive or negative. A rational number is positive if both the numerator and denominator have the same sign, meaning both are positive or both are negative. For example, 3/5 and -2 over -7 are both positive rational numbers. On the other hand, a rational number is negative if the numerator and denominator have opposite signs, meaning one is positive and one is negative. For instance, negative 1/4 and 6 over negative 11 are negative rational numbers. The sign of a rational number tells us its position on the number line. Positive rational numbers lie to the right of 0, and negative rational numbers lie to the left of 0. Section 5. Standard form of rational numbers. Sometimes we encounter rational numbers that can be simplified. For example, the rational number 10 over 15 can be simplified to 2/3 by dividing both the numerator and denominator by their greatest common factor, which is 5. The simplified form of a rational number is called its standard form. A rational number is in its standard form if the numerator and denominator have no common factors other than 1. Expressing rational numbers in standard form makes them easier to work with, especially when we are comparing or performing operations on them. Section 6. Comparison of rational numbers. In this section, we will explore the methods used to determine the relative size of rational numbers, which are numbers that can be expressed as fractions. Comparing rational numbers means determining which rational number is greater or smaller. This is a fundamental skill in mathematics that helps us understand the value of different quantities. But how do we compare fractions with different numerators and denominators? This can seem tricky at first, but with a systematic approach, it becomes much easier. One way is to convert the fractions to equivalent fractions with a common denominator. This means finding a common base for the fractions so that they can be easily compared. The fraction with the larger numerator will then be the greater fraction. This method works because the denominators are the same, so the size of the numerator directly determines the size of the fraction. For example, to compare 2/3 and 3/5, we find the least common multiple of the denominators, which is 15. This step is crucial as it sets the stage for a fair comparison. We then convert both fractions to equivalent fractions with a denominator of 15. This involves multiplying the numerator and the denominator of each fraction by the necessary factors. 2/3 becomes 10 over 15, and 3/5 becomes 9 over 15. Now, with a common denominator, we can easily see which fraction is larger. Since 10 over 15 is greater than 9 over 15, we know that 2/3 is greater than 3/5. This method is reliable and straightforward. Another way to compare rational numbers is to convert them to decimals. This method can be particularly useful when dealing with complex fractions. The fraction with the larger decimal value will be the greater fraction. By converting fractions to decimals, we can use our understanding of decimal numbers to make the comparison. Section 7. Rational numbers between two rational numbers. You might be surprised to learn that between any two distinct rational numbers, we can find infinitely many other rational numbers. Think of it this way. If we take the average of two rational numbers, we get a new rational number that lies between them. We can then repeat this process with the new rational number and one of the original rational numbers, and so on, infinitely. This concept of finding rational numbers between two given rational numbers highlights the density of rational numbers on the number line. Section 8. Addition of rational numbers. Adding rational numbers is similar to adding fractions. If the rational numbers have the same denominator, we simply add the numerators and keep the denominator the same. For example, to add 1/5 and 3/5, we add the numerators, 1 plus 3 equals 4, and keep the denominator, giving us 4/5. If the rational numbers have different denominators, we first need to find a common denominator before adding. We can do this by finding the least common multiple of the denominators or by multiplying the denominators together. Section 9. Subtraction of rational numbers. Subtracting rational numbers follows a similar process to adding rational numbers. If the rational numbers have the same denominator, we subtract the numerators and keep the denominator. For example, to subtract 2/7 from 5/7, we subtract the numerators, 5 minus 2 equals 3, and keep the denominator, giving us 3/7. If the rational numbers have different denominators, we first need to find a common denominator. We can then subtract the numerators and keep the denominator the same. Section 10. Conclusion. The importance of rational numbers. Rational numbers play a crucial role in mathematics and in our daily lives, influencing many aspects. Understanding how to represent, simplify, compare, and perform operations with rational numbers is essential for solving a wide range of problems effectively. Remember to practice regularly and seek help when needed to master these concepts. The more you work with rational numbers, the more comfortable and confident you will become with them. So keep exploring the world of rational numbers and enjoy the journey of mathematical discovery and learning.